at PayPal as a software engineer and a PhD scholar at University of Cumberland. My research is in AI and ML, basically cloud adoption, how companies are adopting cloud and cloud native, which inspired me to give this talk today. And today we are exploring like something fascinating, a double-edged sword. Can you guys hear me okay? Okay. In security. So in both powerful defense, our newest attack, because and this venue is perfect in Austin, right? All talent and innovation, right, happening in the city. Let's get started. Before I start, I want to share a small disclaimer that this is all my personal research. Whatsoever, it is not related to PayPal, where I work. And yeah, so let's start with the problem we are facing. Cloud native architectures have brought us incredible agility and scale, as you know. They also brought us unpredicted security complexity, right? So if you see at the slide, the traditional security parameter, where it's gone, we no longer have castle with wall to defense. Instead, we have this constant shift of collection of APIs, microservice, containers, serverless function, right? And here's the real challenge. Our security teams are drowning in what I call as data firehouse, right? Lots of logs, lots of metrics, traces, creating overwhelming volume that no human can process proactively or efficiently. How many of you here got impacted by the AWS outage? Oh, I see some hands up. Okay. Yeah, we too. The speed mismatch is brutal, right? The attack happened in minutes, but traditional security responses take hours or even days to fix it. Whether you're part of Fortune 500 or a startup, everyone in this room is dealing with this reality today, where this AI has become not just useful, but absolutely essential. Let's talk how AI is transforming in this picture, right? I'm not talking about the incremental improvement. This is a paradigm shift, right? Look at the transformation. The traditional security was reactive, manual, and operating at human speed with static rule set. Where we are getting maybe around 85 to 90% of accuracy. It was taking us hours to detect threats, right? AI-powered security, completely different, right? It's proactive, predicting, preventing attack before it happens. It's automated, running continuously at machine speed, right? It uses adaptive learning that catches threat we have never seen before. How many in this room have used LLMs, small LLMs, just at your work in daily place, like day-to-day living? It has been crazy, right? I mean, I'm a software developer. I write code every day, and my productivity has gone, I would say, 40 to 50%. No writing documentation, less testing, but I always have that AI testing in mind while using AI. Always measure twice, cut once kind of mindset, right? Because of a lot of things, and these numbers are impressive. The recent study in 2025 shows that we are hitting 97.3 detection accuracy. That's a huge jump. We are detecting threats 60% faster than a traditional methods. And these organizations are seeing 83% reduction in threat reduction time. These numbers are just theoretical. They are from labs, like somewhere they are real results from recent studies I did from production environments, organization like yours. AI is a force multiplier that defenders desperately need to match the speed of cloud native development. It's how it's how we level the playing field. So I have 3 parts. Let's dive into part 1, how AI and machine learning are actually reshaping DevSecOps and practice. We will cover 4 key components: intelligent code, security, container, and IAC, infrastructure as code. Anybody here work on Terraform, Ansible, anything? Amazing. I love those tools. Pretty good, right? And autonomous runtime defense, what I call as AI native SOC. So let's start with code security, because this is where the frustration has highest for years. So in the before section, as you can see, traditional SAST, like static application security testing, was creating massive friction. Developer under deadline, pressure would get 50 security frictions, right? And they investigate and find 48 of them were false positive. A lot of time wasted, hours wasted, right? Complete frustration in mode. You know what happens? They start ignoring the security warnings altogether. This is the opposite of what we want. As you can see in the after, AI SAST changes everything. It's been trained on billions of lines of code. So it understands the context, data flow, not just the pattern matching. Now the same developer get those two genuine alerts, that one matters, right? And here's the game changer. The AI doesn't just detect the vulnerabilities, it generated the fix with full explanation and create an automated pull request. In fact, for my research, I recently have an open source project which kind of does that right now, using open source tool to generate those vulnerabilities. I have an AI reading that report, generating. I don't trust AI yet, but always good to do. So the AI go ahead and generate a pull request where I can review everything, make sure everything is good, retest it and merge it. So it's happening. Everybody, I believe, you see a lot of companies. I was talking outside in the booth. Most of them, I think, offers this, which is pretty amazing. Tools like SEMgraph are showing 98% false positive reduction to something they called reachability analysis. Sync and Akido are generating this automated remediation PRs. Dave, correct me if I'm wrong. We have Sync over here, right?
Yes.
Oh.
You're from Signal. I just talked to him.
Oh, okay. And yeah, and honestly, I never met them before this. It's just through research, and I was surprised to see that. So I should tell them this. All right. Yeah, and they are generating remediation PRs. This isn't just theory. Major enterprises are deploying this right now, including teams at GitHub and Netflix. So security shifts from blocker to accelerator. Now let's talk about the building blocks. Container, infrastructure as code. Because these cloud applications are assembled from this company, and security depends on getting them right? So container section. So I hope you can see this. Because of the resolution issue on the screen, the slides are a little wonky. Sorry about that. For containers, AI goes way beyond just scanning for known as CSVs. It does reachability analysis, determining whether the code vulnerability is actually called by your application, right? If it's not reachable, the alert get deprioritized. This is a huge for noise reduction, right? AI also recommends better base images, guiding you towards like chain guard, the wolfy images that can reduce the vulnerability over by 90%. IAC, right? Infrastructure as code. I saw somebody, a lot of you erased hand. AI spot this complex multi-resource configuration chain that simple rule-based linters completely missed, right? Example, here's a public S3 bucket. A public S3 bucket overly, with permission Lambda IAM roles plus a default RDS security group. Each one alone might not be flagged, but together they create a critical exposure path, and AI can catch us before this in deployment. Tools like, again, Akido, Snake, and Chain Guard Stack are leading the space with the real practical implementation. Shifting left is crucial, but the runtime is ultimate the battleground. This is where the application live, processing real customer data and facing active threats in the wild. The challenge, in cloud native environment, containers are spinning up and down in seconds, right? Serverless function execute in a millisecond, and traditional agent-based monitoring just can't keep up. But here is an opportunity for cloud-native observability infrastructure is like perfect fuel for AI, right? All that telemetry data is too vast for humans to process. That's exactly where we need AI, right? So here is the workflow. Your app emits log, metrics, and traces. The flow into the observability stack, like Prometheus, Jaeger, whatever you're using today, then AI-powered security engines learn what normal looks like for every single workflow we have, right? The process execution pattern, the network flow, API call pattern, you call it, all of it could be analyzed, right? Examples, right? So when something deviates from non-normal, the AI catches it instantly. Pod that never makes outbound calls suddenly connects to an unknown IP, flagged. Immutable container swarming a shell, critical alert, right? So here are some, like if you can see some examples, here are some examples. And instead of raw JSON alerts that analysts have to decode, modern system uses LLMs to generate human readable sensitive narratives completely with different attack mapping, and with it also provides some recommended action so human can take in charge, right? So recent IBM study research shows that organization with extensive AI automation see breach life cycles 108-day early shorter, right? That's over 3 months saving in detection and strong response time. The AI native, all of this converging into what I call as AI native SOC. And what I want to be clear about is what I meant by that. This isn't just traditional security operations center, but that bottled to some AI feature. But this is SOC where AI is a fundamental engine that driving every operation from ground up. So the 3 core pillars, as you can see, cloud detection and response, that's hurting for threats within cloud environment, tracking lateral movements from the workloads, automated incident responses, which is AI-driven playbook, executing without human intervention, contaminate happening every second instead of hours, and predictive threat intelligence correlating with global threat, where specific tech stack is enabled to do proactive defense. Here is a fascinating part. The same observability pipeline that SRE built for performance monitoring, those are now the primary data source for AI-driven security. The traditional barrier between DevSecOps, SRE, and security teams are dissolving. Forward, this means if you're a security professional, you need to become an expert in observability tools. If you're an SRE, congratulations. Now, you're the front line of defense, security defense. The future is single unified data plane for both performance as well as security powered by AI. Now, let's shift perspective. We have seen how AI strengthens our defenses, but here's the reality. Advisory are weaponizing AI too, right? Understanding this threat isn't optional, it's critical for defending against them. So the dark side. So in the advisory AI, we can see the primary advisory attack, like as you can see in the slides, the eviction attacks, data poisoning, model extraction, model inversion, and backdoor attacks. And here are some examples of these attacks with the goal. Starting with eviction attack. Goal for okay. So researchers place a small Snickers on the stop sign, right? And advanced computer vision classified as limit 45. this just one pixel change can fool a deep neural network, and a cloud security attack could modify, with AI-powered antivirus classifies as begin. Data poisoning attack, corrupt data to create backdoors and degrade performance. And some example would be like attacker alters the medical images in public data set that relates to the cancer detection AI consistently missed during tumor science. Model extraction and inversion. Here are some examples which does the privacy breach. So analyzes the model output to reconstruct training and data, which is researchers reconstructed face from the training set, but using only the query access, never saw the original training data. Here are some prompt injection, weaponizing language for prompt injection, like direct prompt injection, which is example, and as you can see in the system prompt, where Microsoft intent and the attack with the result is instantaneous. So the single, like using this prompt injection is very trending these days, where attackers are using prompt to inflate the system. And the second example is indirect prompt injection, where in, let's say in email assistant, the user like summarize my latest email, attacker like send email with a hidden prompt. I think I have seen, one of the other things I have noticed is HR AI agents, where a lot of people in the resume are using like hidden prompts to guide the LLMs, which went viral on LinkedIn recently, if you watch LinkedIn news, where because companies are using AI agents to analyze resume, job seekers are using AI to kind of take care of the selection part to it. So these are some examples for here are some top 10 LLM applications by OWASP for like prompt injection, insecure output handling, training data, and model denial of service. These are like top 5 with some strategies as per the research. The AI supply chain attack from the foundation to deployment. So how many of you have experienced the Log4j issue with SolarWinds here? See some constant hands. That's nice. Yeah. So as you know, right, the supply chain reality, these are right, which are exposed vulnerabilities, and AI models face similar but novel crises, right? So the training data poisoning, injecting the malicious data into the training data sets. Results, model produced bias output, and backdoor triggered with specific inputs with unpredictable prediction, right? And second is the model extraction and theft, like systematic query to replicate proprietary models. Like as you can see in the process, attacker uses the query model repeatedly with graph analyze output and deduct internal logic, which impacts like stealing intellectual data or like sensitive data, PI information as such. And ML libraries, like ML models are very sensitive. It requires a lot of compute power to run, right? So this compromised ML libraries like TensorFlow or PyTorch, if you use in your system, these malicious pretend models are inbuilt, like such as Hugging Face and Model Space, so on. They have, coming from an untrusted source, are likely to be, like malicious with unknown vulnerabilities and which could impact the ML pipeline. Part 3, we have seen threat Now let's talk about solution. Part 3 is how actually the secure AI assistant development from end to end, the real strategies, real implementations, and real results. So a case study for cloud native customer support platform on Kubernetes, some couple of AI component, right? AI coding assistant like GitHub Copilot can help developer with Python microservice, Python, Java, could be anything. LLM powered chatbot, fine tune internal knowledge base that answers the customer query, right? In the phase 1, we can have assets such as internal knowledge or historical support tickets, customer interaction log, which could result in faster and developer productivity in general, right? And phase 2, we can have code build, like developer use AI coding assistant, team downloads a pre-trained LLM model, CI/CD CI/CD pipeline with container images. Some threats to keep in mind are vulnerable AI generated code. So, recommendation would be to, double verify everything which works with the process we have. And compromised base model, malicious payload exploiting, like pickle deserialization. Some of the controls we can think about are integration scans. All code obviously must be reviewed before merge. Automated remediation with context-aware fixes, model scanning for malicious code or using some third-party software which specialize in it, cryptographic model signing to make sure the AI models are not malicious, ML/BOM for model dependency. And phase 3 is deployment and runtime. Applications deployed in Kubernetes cluster for scalability, public-facing chatbot interacts with user, right? Some of the threats, direct prompt injection like jailbreak attempts. Threat 2 is indirect, like hidden triggers in support tickets. So key takeaway, like defense and like deep, right? Multiplier layer at each phrase. AI specific controls. Oh, sorry. Yeah, my bad. And end-to-end full coverage, like securing all overall life cycle, not just the deployment, right? And automation, AI-powered tool to scale with development velocity. And finally, zero trust, right? Recommend always principle of least privilege, never trust, always verify, even internal AI systems. So, no single control is sufficient, right? Multiple overlapping layers ensuring no single point of failure. So here are the 6-layer defense framework. Layer 1 is secure AI pipeline. Layer 2, input-output controls. Layer 3, continuous monitoring and detection. And layer 4 is where really important, where you're training based on your internal data. When layer 5 is zero trust architecture. And finally, layer 6 is incident response automation. As you can see, all the layers have in detail, like based on what you want to focus on. Some layers might be important for your team, whereas other layers might be different. So starting with layer 1, we have secure AI pipeline, that is ML/SecOps. Layer 2, input-output controls such as prompt validation, sanitization, and pattern detection. Layer 3 is continuous monitoring and detection, where we can see some real-time behavior analysis and anomaly operation. Layer 4 is, this is the most critical layer for companies starting to use AI, where red teams AI models systematically, and they train their models based on the known attack patterns. This is a critical phase because like robust training is needed for all the edge cases because it changes from system to system. And most important thing is to continue the security validation and always follow the OWASP LLM top 10 testing models. And similarly, we have some more layers and some benefits. For layer 5, we have, in simple words, like zero trust, right? Never trust, always verify. That goes without saying with these AI systems, right? And layer 6 is where incident response automation, right? AI powered like forensic and investigation, where runbooks and playbooks which can match at machine speed. So here are some benefits and resources coming from where this industry standards such as NISFT and OWASP and OpenSSF. Let's talk about best practices for secure AI development, right? A recommendation is start today. Like generally, shift left security, where embed security in design phase, but not after deployment. And the tracking the model dependencies like software component, documenting all the components, models, libraries, and training data, like using standardization given by the respected government contractors or any mandates we have, taking care of all the compliances. Testing, we have dedicated team to test your AI system systematically. Recommendation is to test against the top 10 vulnerability detected by, shared by OWASP. And privacy preserving techniques to protect sensitive data, like different federated learning and data minimizations, specifically PII detection and filtering that, like basically automatically redacting sensitive data, having that logic in place would be really beneficial. Governance and policy, where establishing organization control for AI security, having that governance team in place would really help company to make sure all the compliances, policy, roles, and everything is oversight. Continuous monitoring, where we have continuous monitoring to track performance, drift detection, anomaly detection with audit trails. Automating this alerts is super important for adopting AI into the organization. So finally, I would like to go over some key takeaways from today's session. The AI security is important, right? So AI transforms defect 97.3% detection accuracy, 60% faster than traditional methods, and super essential for cloud native security. Some adversary used for AI, right? ML attacks, prompt injection, top number one in LLM risk. AI arms race is underway, right? Every company is moving towards AI, but always having one important point is having that AI governance team who really kind of knows what things to track, metrics and automated alerts are must. Secure AI itself, right? Models are attack surfaces, right? Supply chain vulnerability, applying security principle to AI. Some defense strategy. So multi-layered defense such as machine learning sec protocols, some input-output controls, zero trust architecture as we discussed, and especially continuous alerting and monitoring. Recommendations start today, right? Think about how we can have the inventory AI system analyzing the low-hanging fruits or small use case to start with, where you can start involving AI, but always keep in mind regularly test for the OWASP top 10 vulnerability scans and establishing AI governments in place to take care of other issues. So the future AI is is according to Gartner Protection, right? Shifting to the primitive cybersecurity, AI predicts and neutralizes threat before they manifest. Autonomous cyber immune system, they say that it's proactive, adaptive, and decentralized. So rise again agentic AI, right? This agentic AIs give us a lot of power, but also we always need to keep in mind performing this complex task, keeping principle of least privilege and keeping AI in check through secure governance and more critically than ever, right? My final message, the question for every developer in this room, security engineer, leader, no longer, if you will adopt AI, how securely you will do it. So because the stakes are high, right? The integrity and security of our next generation depends on it. And with that, thank you so much for attending this talk. I'm open for any questions.